That's me. I bet you wonder how I got here. Have you ever questioned just how vast the universe truly is? Imagine, what if everything we know is just a tiny piece of something much bigger, like a cosmic puzzle? We're diving into mind-blowing details that will answer your biggest questions about its scale and complexity. Could our entire universe be just one cell in a much larger entity? Find out now. I'm going to use 17 celestial bodies to explore the vastity of the universe and highlight just how magnificent and awe-inspiring it truly is. To start, we need a reference point, and the most logical one is the Sun. Yes, a celestial body we all know very well. So, how big is the Sun? The formula for the volume of spheres is here. And r to the third power represents r times r times r, where v is volume and r is radius. The Sun's diameter is 109 times that of Earth. This means the volume of the Sun is approximately 109 times times 109 times times 109 times, or it's around 1.3 million times the volume of Earth. Sorry, you lost me at the first 109. If the whole thing confuses you, the easiest way to put it is the Sun could contain roughly 1.3 million Earths. Here is an actual scale image of the solar system's celestial bodies. From this perspective, it's hard to grasp that the Sun could fit 1.3 million Earths inside it. But what does 1.3 million really looks like? Well, let's just say, if you count one number per second, and reaching 1.3 million will take you 15 days, 1 hour, and 6 minutes, if you do this without any stop 24/7. The scale of the universe is usually measured in two ways, by the diameter of a celestial body and by its volume. Understanding the relationship between diameter and volume is essential, because the volume of a sphere increases proportionally to the cube of its diameter. Keeping this idea in mind helps us better understand the incredible scale of the universe. Now, let's move on to the first star on our list, Sirius A. Sirius A has a diameter 1.8 times that of the Sun and twice its mass. Located in the constellation Canis Major in the southern celestial hemisphere, it's only 8.6 light years away from us, making it the brightest star in the night sky. Next, we have Vega, which has a diameter 2.7 times that of the Sun and a mass 2.1 times greater. The lifespan of a star is inversely related to its mass. A star with 3 times the mass of the Sun will have a lifespan 750 times shorter. As a result, Vega's lifespan is only about 1/10 of the Sun's roughly 1 billion years. Vega is already 500 million years old, meaning it has about another 500 million years left before it ended its life into a supernova explosion. Interestingly, Vega was the first star other than the Sun to be photographed by humans. The next star is Arcturus, which has a diameter 26 times that of the Sun and a volume 18,000 times greater. Arcturus is the brightest star in the constellation Bow. Despite its large size, its mass is not very high, possibly equal to the Sun's, and at most 1.5 times greater. In 5 billion years, our Sun will become a red giant, likely resembling Arcturus. After red giant explodes, its core becomes a white dwarf. A white dwarf has a volume similar to Earth, but with surface gravity about 180,000 times stronger. Under such pressure, no objects can exist intact, and even atoms are crushed, with electrons become free particles. White dwarfs are extremely stable and can last for billions or even hundreds of billions of years. Eventually, they lose all energy and become dead stars, known as black dwarfs. Our Sun will ultimately become a black dwarf. The next star is Rigel, which has a diameter 74 times that of the Sun. Despite its large size, massive stars are often puffed up. Rigel has a mass of only 18 times that of the Sun. Stars with a mass between 8 and 20 times that of the Sun do not become white dwarfs after they explode. Instead, they form neutron stars. Neutron stars are truly extraordinary, though they typically measure just a few dozen kilometers in diameter. Their mass is comparable to that of the Sun. Imagine compressing that mass into an area in the size of Fifth Avenue in Manhattan. The density of a neutron star reaches 10 to the 14th power to 10 to the 15th power grams per cubic centimeter. Over 100 million tons packed into each cubic centimeter. In these stars, atomic nuclei are squeezed so tightly that they're literally touching one another. It's astonishing, but neutron stars continue to evolve. Due to their intense heat and rapid energy consumption, their lifespan is relatively short, only a few 100 million years. Eventually, they cool down and fade away, transforming into non-luminous, miniature black dwarfs. Next up is Betelgeuse. Betelgeuse is a red supergiant star with a diameter roughly 900 times that of the Sun. If it were placed at the center of our solar system, its surface would extend beyond the asteroid belt, nearly reaching Jupiter's orbit. However, despite its enormous size, Betelgeuse isn't particularly heavy, with a mass only 14 to 20 times that of the Sun. According to astronomers, Betelgeuse is nearing the end of its life and is on the verge of exploding. Given that it's just 724 light years away from Earth, if Betelgeuse were to explode, the resulting supernova will be so bright that it could be seen with the naked eyes during the day. That will certainly be an incredible astronomical event. Next is VY Canis Majoris. Its diameter is about 1,420 times that of the Sun, and its volume is an astounding 2.9 billion times greater. However, its mass is only 30 to 40 times that of the Sun, making it another puffy star. Despite this, VY Canis Majoris is still considered a massive star, and when it eventually explodes, it will form an even more fascinating object, a black hole. At this point, space and time bend under the immense gravitational force, so much so that even light cannot escape this region. The boundary beyond which light cannot escape is known as the event horizon. Observing a black hole is essentially observing the events at the edge of this horizon, the light emitted from the boundary of a world beyond our reach. Next, we have UY Scuti, once thought to be the largest star by volume, with a diameter about 1,700 times that of the Sun. However, in 2020, a new record holder emerged, HIP 26,718, with a diameter 3,070 times that of the Sun and an astounding volume 28.9 billion times larger. Stars of this scale, like HIP 26718, live fast and die young, with lifespans of only about 10 million years. These stars are like cosmic fireworks, brilliant, but for a very brief moment, and then quickly fading away. Now, leaving the star behind, let's look at the NGC 1277, a lenticular galaxy in the Perseus constellation, which harbors a supermassive black hole at its center. This black hole has a diameter 42,850 times that of the Sun, and its mass is estimated to be between 2 and 5 billion times that of the Sun. Even more massive is the ultramassive black hole quasar TON 618. Its diameter is 290,000 times that of the Sun, and its mass is roughly 66 billion times the Sun's mass. Located in the constellation Cans Venatici, the black hole at the heart of TON 618 is the largest ever observed by humanity. Its immense gravity pulls in gas, forming a bright accretion disk around it. As the gas falls into the black hole, it releases energy in the form of electromagnetic radiation, creating an extremely bright light. TON 618 is one of the brightest objects in the universe, classified as a quasar, though its core is actually a supermassive black hole. Next, we have a cat's eye nebula with a diameter of 0.4 light years. From here on, we will use light years as our unit of measurement. Nebulae are remnants of supernova explosions, and the Cat's Eye Nebula exploded about 1,000 years ago in Earth's time. The progenitor star was estimated to be about 5 times the mass of the Sun. The nebula features a highly intricate structure, with large and small loops interwoven in a strikingly beautiful pattern. It's far more complex than what resulted from a single explosion, and how it formed remains a mystery. Next, let's talk about the Helix Nebula. It's about 5.1 light years in diameter. Surprisingly large given its origin. It was formed from the explosion of a red giant star, which is now a white dwarf. It suggests that the original star has a mass no more than 8 times of that of our Sun. Its raw size is puzzling, comparable to an explosion from Proxima Centauri, engulfing our entire solar system. Once nicknamed the Eye of God, the nebula was later referred to as the Eye of Sauron, after the global popularity of the Lord of the Rings films in 2003. Next up is Orion Nebula. With a diameter of 24 light years, it is the closest star-forming region to the Sun within our galaxy. The nebula contains thousands of young stars, most of which formed 2 to 3 million years ago. By studying these young stars, astronomers gain insights into the early conditions that may have existed when Sun was born. Omega Centauri, spanning 150 light-years in diameter, is a globular cluster orbiting the Milky Way, about 18,300 light-years from Earth. Despite its relatively small size, it contains millions of stars densely packed together, unlike the more scattered distribution of stars around our solar system. This dense packaging suggests that the Omega Centauri may once be the core of a dwarf galaxy that was absorbed by the Milky Way, indicating that the stars are tightly clustered in a galaxy core. If we lived near the center of the Milky Way, our night sky would be incredibly bright and stunning. However, the intense radiation might make it impossible for life as we know it to form. But who says life has to be like it is on Earth? Could plasma-based life forms exist? It's hard to say. Next is a small Magellanic Cloud, a dwarf galaxy with a diameter of about 7,000 light years. It contains hundreds of millions of stars and is located roughly 200,000 light years from the Milky Way. As one of the closest galaxies to us, it is also the most distant object visible to the naked eyes. And now let's talk about the Milky Way. The Milky Way spans 100,000 light years in diameter and contains between 100 billion and 400 billion stars. It's estimated that there could be around 11 billion planets within the habitable zone, similar to Earth. So, within such vast expanse, it seems like that other intelligent life exists. Just think, if there are 11 billion Earth-like planets, it's hard to believe that none of them host life. If they don't, then the only explanation will be the Earth was created by God, because there is literally no other answers. Current observations show that the Andromeda Galaxy is moving toward the Milky Way at a speed of 300 kilometers per second. In 3 to 4 billion years, the two galaxies will likely collide and eventually merge into a new elliptical galaxy. Let's move on to IC 1101. IC 1101 is a supermassive elliptical galaxy located at the center of the Unveil 2029 galaxy cluster. Its halo stretches out to 600 kiloparsecs from the core. Scientists estimate its diameter to be about 2.8 million light-years, 28 times larger than the Milky Way. IC 1101 is currently the largest and brightest known galaxy in the universe, containing around 100 trillion stars. At numbers like trillions, it becomes difficult for our brain to grasp the scale, especially you. Now, let's talk about Bow Void.
The Boötes void spans 250 million light-years across and lies in the middle of the northern sky's Boötes constellation.
It is a cosmic mystery, an immense region of space with almost no galaxies. On average, there are only one galaxy every 10 million light-years. Astronomers have even suggested that if our Milky Way were located at the center of the Bow Void, until the invention of large telescope in 1960, we would have thought the universe contained just one galaxy, us. Aside from the Milky Way, nothing else would be visible to the naked eyes. So, why is the Bow Void so empty with so little in it? Let me tell you that astronomers still do not have an answer. Let's talk about the observable universe. Its diameter is estimated to be 93 billion light-years, the furthest distance human can observe. But think about this. The universe is only 13.8 billion years old, and faster than the light travel is supposed to be impossible, right? So, shouldn't the radius of the observable universe only be 13.8 billion light-years? Actually, that's a misconception. According to general relativity, matter and energy are interchangeable. The speed of matter is kept at the speed of light. However, the expansion of the universe isn't tied to the movement of matter, and its expansion is allowed it to exceed the speed of light. And that is why the universe stretches far beyond 13.8 billion light-years. Well, based on this theory, scientists suggest that if the observable universe were the size of a light bulb, the unobservable universe would be as vast as Pluto. Now, imagine the light bulb sitting at the center of Pluto. What does that make you feel? That light bulb represents the limit of human knowledge. What's beyond it? We may never know, and let alone what exists beyond the universe itself. So, how big is the universe exactly? That is a question that still has no answer. So why did you make this video? I think after watching it, it just made me feel so empty, meaningless, powerless. Like how tiny I am compared to the whole universe. Well, but you can also look at this from a different perspective. In recent decades, some exciting new theories have emerged that could redefine the relationship between the universe and humanity. For example, string theory. That might provide a new way to travel through multi-universe or multi-dimensional space-time. Perhaps we could jump beyond the observable universe with just a blink of an eye, like Starfleet. Think about this. 10,000 years ago, it was unbelievable for ancient people to imagine flying around the Earth in an aeroplane. Did you forget about Anunnaki? Move on. Maybe another 10,000 years, humanity could spread across the entire universe.
Star Stuff Pondering the Stars. Organized assemblages of 10 billion atoms considering the evolution of atoms, tracing the long journey by which, here at least, consciousness arose, Carl Sagan.